Hello, my name is Roy Simpson. I'm a professor of mathematics at Cosumnes River College in Sacramento, California. This is a lecture for intermediate algebra on the quadratic formula. I've broken this lecture up into 4 parts. They'll all be each a little bit smaller than what I normally record for lectures, but that's probably pretty good considering that some of my lectures can run pretty long. The first part will be the proof of the quadratic formula. Second part will be using the quadratic formula. This is both for solving quadratic equations and applications. The third part is an introduction to complex numbers, so negative roots essentially, or negatives underneath roots. And then finally, part D will be a discussion about something called discriminant, which can be very useful for determining the number of solutions and types of solutions to a quadratic equation. And what I'm going to do is go ahead and start the proof by not even claiming what the theorem is, because a lot of students, when they see the quadratic formula written as a theorem, they want to use it all the time. Instead, we're going to tackle this by just proving it or showing that it's true in general without knowing what the formula is. So here we have a quadratic equation, ax squared plus bx plus c is equal to 0, and I want to solve this. And up to this point, you really only have 2 methods to solving quadratic equations. Either extraction of roots, which is essentially you can only use if you have one version of your variable and it's underneath a power like this, like an x minus 2 being squared minus 1 is equal to 5 or something like that. Then you can go ahead and use extraction of roots because there's one of your variables. Otherwise, if you have 2 versions of your variable, an x squared and an x, then you can use completing the square. And if you need a review of that, please go to my video on completing the square and you can review that topic there. In this case, we are actually going to, since we only know those 2 techniques, and I happen to have 2 versions of my variable x here, I have an x squared and an x, I'm going to go ahead and use completing the square to solve this quadratic equation. The first thing that we must do when we try to complete the square is, well, it's one of 2 things in reality. You can either isolate all the variable terms on one side, which means that I'll subtract c from both sides. So I do that. So I have ax squared plus bx is equal to a negative c. Or you could have divided by the coefficient on x squared first, but I'm actually doing that second. It's not that big of a deal. So like I just said, at this next step, I'm going to need to rip off the a that's being multiplied against my x squared here, and the way that you undo the multiplication is to divide by a. And of course, if you divide one object in your equation by a, you have to divide all terms in your equation by a. So let me say that a over a, those common factors cancel, and you get this beautiful x squared plus b over a times x is equal to negative c over a. And now we're going to go ahead and start completing the square. The completing the square phase essentially says that we are going to add something to both sides of this equation, and that something is some object being squared. And if you recall from the video on completing the square, you're going to add half of that term, that coefficient on x there, you're going to add half of that squared. So that b over, instead of a, I'll call it b over 2a, because that's really half of b over a. So if I add b over 2a squared to the left side, I have to also add b over 2a squared to the right side. Now, as an aside, I need to convince you that half of b over a is b over 2a. 1/2 of b over a is equal to, well, 1 times b is b, and 2 times a is 2a. So I just wanted to show you that that's why I have b over 2a there, because that's what half of b over a is. Now at this point, I can actually complete the square. Well, I've already done it, but I can factor this left-hand side. And recall again from my previous video lecture that you would steal that x right there and steal this positive b over 2a. And of course this would be squared. And this is going to equal negative c over a plus, and now I'll square these terms, so that's going to be a b squared in the numerator over a 2a being squared in the denominator. Now, of course, I can clean that up quite a bit, in fact. So let me do that. That's x plus b over 2a being squared is equal to a negative c over a plus b squared over 4a squared. I'd like to add these two fractions, but the only way that I can do it is if they have like denominators. So I'm going to force them to have like denominators by multiplying the denominator on that first fraction by 4, which means I have to multiply the numerator as well by 4. And notice that second fraction has a denominator of a squared, so I'm going to have to multiply this first fraction to have a denominator of a squared as well. So if I multiply the bottom by a, then I have to also multiply the top by a. And this implies, maybe I'll write the implication over to the right hand side here. So I'll drag this up. This implies that we have x plus b over 2a being squared, that quantity, is equal to a negative 4ac plus b squared all over their common denominator, which is 4a squared. In reality, I could have written that numerator as b squared minus 4ac, and in fact, I think I will. So I hope you don't mind, I'm just going to rewrite that as a b squared minus 4ac. Now, my ultimate goal here is to get x by itself, so I'm going to take the square root of both sides. This tells me that x plus b over 2a is equal to, and remember when you take the square root of both sides here, you'll have a plus or minus square root of b squared minus 4ac, all divided by 4a squared. And before I continue forward, I want to remind you that if you have the square root of a number, maybe I'll use a different page just to show you this. If you have the square root of a fraction, I shouldn't use the letters a and b here because I'm already using them elsewhere, but you can split this fraction to the square root of the numerator over the square root of the denominator. So I'm going to go ahead and do that in this example. I'm going to break this fraction up to where I have the square root of b squared minus 4ac in the numerator, and the denominator will have the square root of 4a squared. The beautiful thing about that is the square root of 4 I happen to know is going to be 2. The square root of a squared is actually a, although in reality it's not just a, it's going to be plus or minus a, but I already have a plus or minus out front, so that's not a heavy concern for me. So this is actually going to be x plus b over 2a is going to equal plus or minus the square root of b squared minus 4ac, and that whole thing is being divided by 2a. Now the last step here is I'm going to subtract b over 2a from both sides. And when I do this, when I subtract b over 2a from both sides, I get the following. And in fact, I might as well just start on a clean page just to show you. So when I subtract b over 2a from both sides, I get the following. X is equal to negative b over 2a plus or minus the square root of b squared minus 4ac all over 2a. Notice these two fractions have the same denominator, so I can write them together as a single fraction, and that'll give me the following, that x is equal to a negative b plus or minus the square root of b squared minus 4ac, all being divided by 2a. And this is what we call the quadratic formula. The quadratic formula basically says, I'll write as a theorem here, quadratic formula given ax squared plus bx plus c is equal to 0, x is equal to negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And how do we know that's true? Because we just solved this very general equation here, ax squared plus bx plus c is equal to 0. We solved that for x. And the entire time we didn't know what a, b, and c were. But it didn't matter because we got to a solution. Our solution was negative b plus or minus the square root of b squared minus 4ac, all being divided by 2a. And that's a very important thing, by the way. I try to say all being divided by because a lot of students tend to forget that 2a is the denominator of everything there. So in the next video, I will go ahead and use this formula to solve equations.